Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 4 Additional Mathematics Chapter 6 Linear Law HOTS question example 5. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. The following table shows the corresponding experimental values of two variables x and y that are related by the equation p over y equals to q over x plus 1, where p and q are constants. So this is the respective values of x and y. So continue to read the question. Based on the given table, construct a table for the values of 1 over x and 1 over y. Continue to read the question part B. Using a scale of 2 cm to 0.1 unit on the 1 over x axis and 2 cm to 0.5 unit on the 1 over y axis, plot the graph of 1 over y against 1 over x. Hence, draw the line of best fit. Continue to read the question part C. Using your graph in B, find the value of P and of Q. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve this question. Let us begin our discussion for the question part A, where they ask us to construct a table for the values of 1 over x and 1 over y. Okay, so please give me some time for me to construct a table, since the question specifically mentioned for 1 over x and 1 over y, because usually what we do is we will construct 4 tables. Mainly the first two is the one already given by the question and the following two is the one required by the question. But then in the question part A, they only specify the one mentioned by the question, which in this case is 1 over x and 1 over y. Okay, so please give me some time, guys. Okay, so let us continue. So for the first row, let us write here 1 over x. Okay, as for the second row header, we will write here 1 over y. Okay, so we calculate according to this data here. So from here, the first value will be 0.67. Then you can ask me, so how you get 0.67? Okay, basically 1 over 1.5, so you should get 0.67, and this follows for all the x values respectively. Okay guys, so continue with 0.5, 0, 0.50, okay, and then 0.33, 0.25, 0.20, okay, and then the last one 0.17. Okay, so this is the values for 1 over x. Okay, continue for 1 over y. Similar concept. So for the first one, okay, 1 you divide with 2.564, you should get a value of 0.39. Okay, so the similar thing you apply throughout for all the y values respectively. Okay, so from here the second value you should get is 1.25. Okay, and then followed by 2.12. Okay, and then 2.55. Okay, and then 2.81. Okay, and then your last value will be 2.99. Okay, so from here we have already solved the question part A. Okay, let me arrange the table. Okay, move it to this side. Okay, alright, okay, now it's better. So for the question part B, they ask us to plot the graph of 1 over y against 1 over x. Okay, by the way, I've already completed the graph for you. So allow me to show you the final graph now. Okay, let me put this in the full screen mode. So this is the complete graph, guys. So as you can see here, a graph of 1 over y against 1 over x. So 1 over y in this case is the y-axis, and 1 over x here is the x-axis, and as you can see here, the graph is in the negative slope. So you should be getting your graph something like this. Okay, so let me close this for now. Okay, and then proceed with the question part C. Okay, so for the question part C, they ask us to find the value of P and Q using the graph that we have drawn for the question part B. Okay, so this question is a bit different, guys, because they already mentioned the options for you. Usually what we do is we need to change the non-linear equation to linear form, and then we create the table, and then only we plot the graph. But then this question, it's a bit different, so that's why I recommend you to try this question. Okay, so the first step on what we need to do is, okay, now we need to change the non-linear equation to linear form. Okay, so that will be our first step. So let me write the working here. Okay, so given by the question, P over y equals to Q over x plus 1. Okay, so for the next step, what we're going to do is, so we're going to divide the whole equation by P. Okay, so from here you should be getting 1 over y is equals to Q over Px plus 1 over P. Okay, the reason I divide with P, so that at the end I must come up with the equation such that it fulfills the axis 1 over y and 1 over x. Okay, so at the end we should come up with something in related to the straight line equation form, which is y equals to mx plus c. Okay, so from here we know that 1 over y will be acting as the y-axis, and then the 1 over x will be acting as the x-axis. Okay, so from here, so continue to the next step. So what we can do is, so the q over p we can factor out from this expression. From here you should get 1 over y is equals to, okay, you factor out the q over p. Okay, so you only left with 1 over x. Okay, and then you plus with 1 over p. So as you can see here, we have already formed the y equals to mx plus c form, which in this case 1 over y is the y axis. Okay, and then q over p will be the gradient of the straight line. Okay, 1 over x will be act as the x-axis. Okay, and then 1 over p will be the y-intercept. Okay, so this is our first step, guys. Okay, so once we have already get the equation to linear form, so let us proceed to the second step. So our second step, what we're going to do is we're going to find the y-intercept. Okay, let me write the second step working here. Okay, so let me open the graph paper. Okay, put this in the full screen mode. Let me zoom it in. Okay, so as you can see here, this is your y-intercept, which is 3.9 in this case. Okay, if you can't see clearly, let me zoom this. Okay, so this is your y-intercept, which in this case is 3.9. Okay, so let me close this. Okay, so we write in the working here, from the graph, okay, so we know that our y-intercept is actually equals to 3.9. Okay, this 3.9 we obtain directly from the graph. Okay, but then there is another y-intercept value which is 1 over p, where we obtain directly from the equation. So for the next step, what we're going to do is we're going to compare this 1 over p with this 3.9 value, guys. Okay, so from here, compare to 1 over p. Okay, so from here, 1 over p is equals to 3.9. Okay, so from here you should get your p in an estimation of 0.26. Okay, so this is your first solution. Okay, let me underline this. Okay, so once we have already done the step 2 where we find the y-intercept, okay, now we proceed to the third step where we are required to find the gradient of the graph. Okay, so let me write the working here. Okay, so to find the gradient of the graph, which in this case the gradient of the straight line, so we use this formula m, where it is equals to y2 minus y1, okay, and then you divide with x2 minus x1, close bracket. Okay, let me underline the fraction over here. Okay, so this is the formula that we're going to use. Okay, now let us open the graph paper now. Okay, full screen. Let me zoom this some more. Okay, scroll this down. So as you can see here, I've choose two new points in order to calculate my gradient of the straight line, which in this case the first point is 0.3, 2.3, okay, and then the second point is 0.45, 1.5, okay, and then I form a triangle. So in order to calculate the gradient, y2 minus y1 will be 2.3 minus with 1.5, okay, and then I divide with x2 minus x1. In this case, my x2 will be 0.3, okay, and then my x1 will be 0.45. Okay, so let me close the graph paper. Okay, and continue our working. So from here, m will be equals to 2.3 minus 1.5, okay, and then divide with 0.3, okay, minus with 0.45, okay, close bracket. Okay, let me underline this. Okay, so you calculate this, you should be getting your gradient of the straight line is equals to negative 5.33. okay, so let me underline this. So this gradient of the straight line we obtain directly from the graph, but then there is another gradient of the graph that we have obtained, which is directly to the equation, which in this case is q over p. Okay, so for the next step, what we're going to do is we're going to compare this q over p with negative 5.33, guys, okay, which we obtain over here. So let us continue. Compare with q over p. So from here, q over p, okay, is equals to negative 5.33. So in the second step, we have already find the p value, where our p value is equals to 0.26. So what we can do in the next step, so we can substitute the 0.26 over here. So from here, q over 0.26, okay, where it is equals to negative 5.33. So to calculate the q, what you do, 0.26 you times with negative 5.33. Okay, so you calculate this, you should get your q in estimation of negative 1.39. okay, so this will be your second solution. Okay, let me underline this. Okay, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Any comments, feedback, please feel free to put in the comment section, guys. Thank you everyone for your support, and I'll see you in the next video.